Mathematician Center for Theoretical Physics run an intensive research program in order to tackle the possible implication of the generalized uncertainty principle GOP. GOP was originally assumed to fit well with string theory, black hole physics, double special relativity, and thought experiments, probing the shortest distances and or maximum momentum at Planck scale. In the present paper, the possibility of finding the measurable maximum energy and the minimum time interval is discussed in different quantum aspects. In 1964, Erwin Shapiro pointed out that the possible time delay resulting from the observation that light appearing to slow down as it passes through a gravitational potential could be measured within our solar system. And the fundamental limits governing mass and size of any physical system, Saliker and Wigner suggested that a minimum time interval can be even registered. They even proposed the use of a quantum clock in measuring distances between events in space-time. This quantum clock is given as constraints on smallest accuracy and maximum running time as function of mass and position uncertainties. Barhoff applied Wigner's inequalities to describe the quantum constraints on black holes. It's founded that the black hole's running time should be correspondent to the lifetime of Hawking radiation. The Schwarzschild radius is assumed to be correspondent to the Wigner size constraint. The information processing power of a black hole is estimated by the emitted Hawking radiation. The generalized uncertainty principle assumes modification in the Heisenberg uncertainties as follows, and also in the corresponding algebra. In the present work, we give estimations for the measurable maximum energy and the minimum time interval due to GOP for the Schwarzschild black hole. The quadratic GOP approach assumes that this is the uncertainty in the energy and the uncertainty in the time interval, measurable time interval. It's found that both maximum energy and minimum time have the order of the Planck time, since the uncertainties in both quantities are accordingly bounded. With this reference, we addressed physical insights, also the implication on the physics of early universe and on quantized mass. Also outlined the results are related to the existence of finite cosmological constant and minimum mass quantum. It's concluded that the uncertainty in time measurement depends on the distance separating the observer from the event, the clock's accuracy and size, and the time taken by photon to reach the observer. In the present work, we found that the linear generalized uncertainty principle approach gives non-physical results. The resulting maximal energy violates the conservation of energy. The minimum time interval shows that the direction of the arrow of time is backward. In light of this, we conclude that the applicability of the linear GOP approach is accordingly limited to or even altered. Kumar and Harko formulated a rigorous proof of a minimum mass or density in general relativity at finite positive cosmological constant. Maximum mass and radius was found by Chandrasekhar and Landau. 6 decades ago, Bohdar estimated an absolute limit of the ratio mass to radius of stable compact object. Accordingly, there is mass related to the quantum scale and one relevant to the cosmological scale, maximum energy. Accordingly, within the quantum mass is mass quanta, mass is quantized. Again, in the present work, we show that the existence of minimum length related to minimum time, for instance, could be a purely quantum